Algebra 1 students, welcome to today's lesson, Graphing Linear Inequalities. Today we're going to take a look at how we graph inequalities. Obviously you have to know how to graph lines first, then we're going to graph inequalities. And then tomorrow, it's only a day away, but we'll practice this in class. So let's get started and take a look. First, some of the symbolic notation. Some of it you've seen before, but let's make sure and review some of it. The less than symbol means that you would have a dashed or dotted line. I'm going to write dashed here. So this would be dashed, where the less than equal to would be solid. Greater than would also be dashed, and greater than equal to would be solid. And then the question is, where do we shade? Well, either of the less than notations we would be shading below, and then the greater than we would be shading above. That kind of makes sense. If it's less than, it's got to be below. If it's greater than, it's bigger, so it's above. You can see over here to the right we have an example of this. The graph of y is less than x. A couple things to point out. First of all, the line y equals x is graphed right here. It's dashed and in red. But you'll notice that it's not actually included in this graph. It's only the red, or maybe pink if you want to argue that, shaded region down here that's actually included in the graph. The shading is in fact below the line. Now, especially when we get steep slopes, you'll have to be careful to make sure you think above or below, and then also, of course, consider if lines are shaded, or excuse me, if they're solid or dashed. All right, so let's take a look at this. This one says y is less than negative 1/2 x minus 3. So we're going to start by doing the graph of y equals 1/2 x minus 3. That tells me that we have a slope of 1/2 and we have a y-intercept of negative 3. I'm not showing you anything you haven't practiced about 1,000 times right here. Y-intercept negative 3, slope is 1/2. That means we go up 1, right 2, up 1, right 2, and we can continue that pattern. You really only need a couple of points to draw a good line. The more you have, sometimes the easier it is to sketch that accurately. Now I'm going to use a little tool. I have a bit of an advantage. So we will do this, and you'll notice that my line is dashed. That comes from the less than symbol that you see right over here. That tells me two things. One, it says the line is dashed. It's not included in this inequality. The second thing is it tells me where to shade, and the shading is of course below, since this is less than. All right, I'm not going to judge you based on your coloring skills. Just kind of give it a decent shot, color in, shade in some of it, and try to stay within the lines to keep your elementary teachers happy. All right, let's take a look at number 2, graph the inequality. Hey, I'm going to try a different method on the graphing this time. I'm going to graph by finding intercepts. It's a great way to do it, because we know, for instance, if x is 0, that would mean 5y equals 10, so we know the point 0 and 2 would be right here. And by the same token, if we find that y is 0, then the only way y is 0 is if x would have to be negative 5. Just as a reminder, this 0, 2 comes from, if x is 0, you have the equation 5y equals 10. So you divide by 5 and you get y equals 2. Over here you've got negative 2x equals 10. And we're saying equals. We're not worried about the inequalities for this particular job. So then our x-intercept would of course be negative 5. 1, 2, 3, 4, 5. There's our point. Negative 5, 0. Let's go ahead and draw the line. Now notice this time it's greater than or equal to, so the line would be, in this case, solid. So that's what I'm going to sketch, is a solid line. If you're working on a homework assignment, a quiz, or whatever, you might want to use a ruler or some type of straight edge to draw these. The tool that I'm using is kind of nice to have access to, but obviously when you're working on paper, you don't have that. So, okay, and then the last thing we have to consider, and actually I say it's the last thing, but we have to really deal with the situation that's a little different here. When we talked about all the inequalities 2 slides ago, we said if it's greater than, it's always shaded above, if it's less than, it's shaded below. But I'm going to go back because there probably should be a clarification here, and I'm going to put it down here in red. It's really important. And this is only in the case of y equals mx plus b. And really, when we say equals, I should probably not even put an equal sign there. I'm going to put a y, and I'm going to put a box to say there's an inequality there. Okay, so coming back to the problem that we have here, you'll notice we're not in slope intercept y equals mx plus b form. So here's what we do. We test a point. And honestly, the easiest point to test, unless it's on the line, is the point 0, 0. So what I'm going to do is say, okay, does 0, 0 satisfy the inequality? So I'm going to do -2 plus 0 plus 5 times 0 greater than equal to 10, and I got to answer that question. Is this true? Well, over here I get 0 greater than equal to 10. Is that true? No. That means 0, 0 right here is not part of the solution. That tells me then the solution has to be above. Okay, now in this case you'll notice that the sign was greater than, and yeah, we shaded above. That's not always the case. Sometimes with standard form, a greater than symbol can still have shading below. And just as a spoiler, if the y value is negative, that's when that happens. I still like testing points. I hope you'll do that too. Now sometimes we get graphs like you see on number 3 here that are not in standard form, they're not in slope intercept or point slope. This is actually just an x equals graph. We know that to be a vertical line. So I'm going to start by graphing the line x equals -7. So 1, 2, 3, 4, 5, 6, 7. Here it is. Remember the Hoivux phrase we used last semester? Still applies. They didn't change that rule yet, thank goodness. And so what then I need to do is say, well, I can't shade above or below because this is a vertical line. So the shading above and below thing we have to reconsider a little bit. And basically what I'm going to do is the testing of a point. 0, 0 is a nice point. Is 0 less than or equal to -7? That's the question we got to ask ourselves. And of course the answer is no. So this is not part of the solution. We would shade to the left. And I'm sure some of you are probably thinking about, when you saw that and said, well, it's less than, obviously it's to the left tail. I get that, and feel free to go ahead and do that. So shade to the left. Vertical line, all the solutions fall left of it though. All right, determine whether the ordered pair is a solution of the linear inequality. Guys, all this is plug it in and see if it works. This is x, this is y. We're going to plug those values into this inequality over here. So I'm going to have 7 times -1 plus 2 times 1 greater than -5. At this point we just need to simplify. -7 plus 2 greater than -5. -7 plus 2 is -5. Is -5 greater than -5? Well, if it had a little equal to sign underneath, our answer would be yes, but it doesn't, so this is no, it's not. All right, same instructions on the next one. As a matter of fact, I want you to do this. Pause the video, do number 5, and then compare your answer to mine. All right, welcome back. You can see my work here. This one looks a lot like number 4, but this one was a yes where 4 was a no, even though we still had like the same number, 3 and 3, -5, -5. The difference is that little equal to sign. This says 3 is less than or equal to 3. It's not less than 3, but it's definitely equal to 3. So that one's a yes. This would be part of the solution. All right, let's take a look. This is our last slide. This time we're going to write the inequality that represents each graph. Now there are a few steps involved in this. The first part though is we need to find the linear equation. So what I'm looking at is I see right here on number 6 that I have a y-intercept, a b value that's at positive 2. The other thing I need to find is the slope. Now I was nice enough to give you pretty straightforward values here, and you can see if you count down 2 and right 1, which would be a slope of negative 2, that you would have the correct slope. So basically our equation for that line is y equals negative 2x plus 2. This isn't an equation, no. It's not just a line. It's a shaded graph. It's an inequality. We need to actually change that equal sign. So then the question becomes, are we shading above or below? And is our line solid or dashed? So in this particular example, it would be y is less than, because it's shaded below, or equal to, because the line is solid, negative 2x plus 2. So again, start by finding the line and then just change it. All right, we'll go through the same thing here. This time our y-intercept is down here at negative 3. And we can see that the slope is up 1 and right 1, 2, 3, 4. So our slope is 1/4. The linear equation would just be y equals 1/4 x minus 3. But in this case, we're not looking for a line. We have an inequality we're graphing. It's above, so that tells me it's greater than, and it's a dashed line, so it's not equal to, and it would look like this. Y is greater than 1/4 x minus 3. Folks, I really look forward to seeing you tomorrow. It's only a day away, and it's a day when you're going to come to work hard. Make sure you know how to graph these inequalities. We'll see you soon.